Hello, I'm Nirbheek. I work on Meson and GNOME, and I work for Centricular. Today, I'm here to tell you why Meson is the build system for app developers. Now, the first question is, what is Meson? How many people here have heard of Meson? Please raise your hands. Everybody, great. How many people here have built a project that uses Meson? Almost all of you. And how many people here have written a Meson build file? Pretty good number, cool. That's a question I will ask at the end of the talk. So what is Meson? New build system hype, woo! No one has ever said that, ever. Especially not Linux distributions. I know because I used to be one at Gentoo. So why is that? Why are people not hyped about new build systems? A little history lesson for that. About 2006, a bunch of new build systems showed up. People were quite tired of auto tools. And one of them was SCONS, nicknamed by distro devs as ISCONS. The other one is called WAF, also commonly known as BARF. Now, I don't subscribe to these nicknames myself, but I know that a lot of people worked on these projects, but fundamentally, they were not built with enough of the use cases of app and library development, including deployment, distribution, etc., in mind. And hence, they weren't interested in these alternate use cases. And hence, people's dissatisfaction with them. And hence, there was a lot of skepticism. Once these build systems came up, they were like, new things don't actually work. And there was depression. People went back to auto tools. Resigned to CMake. KDE, for instance, wanted to move from auto tools to something else. They tried SCONS with bcases. It turned out to be a complete nightmare because the upstream weren't really interested, and they ended up having to use CMake, which wasn't their first choice. And other people took the worst possible option, which was to have custom, handwritten, configure and make scripts. Perl, for instance, has a OpenSSL, for instance, has a Perl script called configure, which generates make files. Is probably like the worst thing you can do. And then FFmpeg has shell scripts for generating configure and make files. And other projects only use autoconf and not automake. It's all a total mess. And either it's one of these, or your project is not C or C++ at all. It's using Cargo or NPM or whatever. And you have your own ecosystem around it. So it was depression, right? And the reason for that is because auto tools will always be bad. For instance, this is what it looks like to use an auto tools project. These are all the components that are run every time you need to build a auto tools project. And this doesn't even include the POSIX tools used, awk, sed, grep, tr, whatever. And it's like 100 of them. And it's really hard to do portability with this. So it will always be bad. But people have kept using auto tools because they don't like anything else. And CMake is better, but not much better. And it's not going to get much better either. It does a lot of things which are anti-patterns. And the elementary folks have written an excellent blog post which explains why they moved from CMake to Meson. You can check that out if you like. The VDLine folks, the people behind VLC, are also moving to Meson. So there's a lot of momentum behind the project as well. But why should you trust Meson? Well, we've all seen this XKCD comic, right? Oh, standards. But this is okay, actually. A new standard is good as long as it actually does things better. And the reason why Meson does things better is because we have learned from other people's mistakes. Meson has been built by people who've used all the other standards, and we know what we're doing. The best bits of all build systems: Automake, AutoTools, CMake, JIP, WAF, and even Visual Studio. We are an approachable upstream that cares about your use cases. We never want someone to have the experience KDE had with SCONS. We have a very diverse set of people as part of the development team. We have distro maintainers, app developers, desktop developers, compiler people, systemd, Mesa, Zorg, Fortran people, mobile app developers, whole bunch of people. And Meson is designed to encourage upstream first. How is that? We have a module system. So anything that you have a use case, it can go upstream very easily. Internationalization, GNOME, Qt, package config, Windows, CUDA, CMake even, kconfig, everything you want, and there's a lot more. Meson also supports all platforms: desktop Linux, BSD, macOS, Windows, Solaris, Illuminos, which is a new Solaris, Haiku, AIX, embedded Linux, server Linux, Android, iOS, HoloLens, Magic Leap, everything. We support all CPUs that I which you can cross-compile for. We support all tool chains. There's a whole bunch over here which you probably never even heard of. For instance, there's EM scripting. You can compile WASM if you want. All the linkers, it supports everything. It's a bit dizzying, honestly. And we do all this without compromise. We have great internal abstractions, and we have the correct amount of fear of reorganizing internals. And we have an extensive test suite which runs on the CI continuously. So that's all good. It allows us to move quickly. But the most important thing is that the syntax is easy to read and write for both the syntax and the intent. The syntax is inspired by Python. It's purposely not Turing complete because it's a bit silly to, if it's inspired from JIP, but it's a bit silly because it's a bit silly to have programs that run programs to build your programs. Because then you just try sort of going along with this meme, or even worse, this meme. You don't want recursion everywhere in your world. So Turing complete, right? And the syntax is declarative with an imperative syntax. I'll show you what that means later. And it's implemented in Python, but it doesn't have to be. We're very careful to make sure that our specification does not rely on Python internals at any point. So syntax, again, most important thing, another thing which is really important for readability is that we have explicit types for objects. No stringly typed things, no quoting mess where you have, oh, I want to add a path, oh, but it's a string, oh, there's spaces in it, now I'm screwed. Never happens in Meson. Dependencies must be stated explicitly, unlike AutoTools or AutoMake, where you have to have variables with the correct names so that you have the right slotting available for everything. It's not like that. And we avoid side effects in global state. AutoTools is all about global state. We try to avoid that as much as possible. So what does this look like? I'll show you a snippet. So this is what most Meson build files will start out with. The project name, the language, and like if you can add more languages at the top. And then this is how you look for dependencies. Find a library, a dependency with a package config file, a dependency that supports other sorts of ways to find them. For instance, qmake, .cmake files, and also dependencies with a fallback. What are fallbacks? We'll talk about that in a second. So the important thing to note here is the third one, qtdep. Now, that's done with a little bit of magic. We have dependency abstractions that can do arbitrary searching. This is all upstream. It even supports CMake's find package abstraction. And dependency fallbacks are interesting. I think one of the most important features of Meson, in that Meson projects can include other Meson projects as sub-projects. And so in the end, you can have a single configurer in Make that builds your project and all its dependencies in one go. This allows you to do really cool things where you have all the dependencies included with your app sources and building on different platforms with the same command, unlike any other build system that I know of. Next, let's take a look at how targets look like if you want to build libraries or executables. This is what it looks like. You have some sources. You can build a library from that and an executable from that and also run a test on that. Now, let's take a look at how this leads to dependencies. So the sources go there, the library goes there, the tool goes there, right? You see how they're all sort of depending on each other. And this is how we deduce dependencies in Meson. And it's very explicit, it's very intuitive as well. Next, you want to do compiler checks, right? Everybody has to do compiler checks unless they want to target only one platform, like Google does, for instance. So if you're not Google, you need compiler checks. This is what it looks like in Meson. You define a configuration data object. You can create a list of headers, for instance, you want to search for, or libraries, or symbols, or whatever else. You loop over them, you check if it exists, you set the configuration, and then you write it out. That's it. It's pretty simple and straightforward. The next thing which sets Meson apart is that it's built to be fast, and it's getting faster every day. The default backend is Ninja. We output a single build.ninja file in the build directory. There's no recursive make or whatever else involved, unlike AutoTools, for instance. We also have a fast install step, unlike libtool. There's no relinking required. We also avoid relinking when your sources change unless the symbols have changed, which is really cool. If your linker times cannot be parallelized, if they're slow, you're going to be sad. And we also have built-in support for profiling. If you run Meson with that command, It will show you execution timestamps for each command, for each output, and it will output a profile data file in Python's native profile format, which has been used to speed up Meson a lot in the past few years. And we have plans to make everything even faster. We have plans to parallelize configure. No other build system does this. How do you do this? Like, for instance, this, right? We were looping over all the headers and doing configure checks. You could easily parallelize this, because each step is independent of each other. Next reason why you should trust Meson: documentation. People love our documentation. It's in tree, and it's built with HotDoc. We have release notes for all features, and merge requests that introduce features are required to have to add the documentation for it. And we have well-organized stable releases. Use GitHub milestones, and if you want to check what's in a stable release, it's one click away. Another reason why people like Meson is good defaults. Unlike, for instance, CMake. We have built-in flags for installation. For instance, libdir prefix, which is there everywhere, but libdir, sysconfdir, libexecdir, bindir, all of those standard things which AutoTools has. We also have good abstractions for cross-language and cross-toolchain. For instance, we have WError, warning level optimization. If you set those, they'll be applied to all the languages and toolchains that your project uses. If you use C, C++, Rust, Vala all at the same time, it will be applied to all of them correctly. We also have good build defaults. For instance, we enable as needed by default. You can turn that off if you want to, but by default, it's there. Same with undefined symbols. And I've taken great care to make sure that everything can be turned off project-wide or per target. Some people require that undefined symbols are allowed. Some targets need that. So we allow you to do that. And we have documentation for that as well, of course. Next reason, which I think is one of the more important things, is that we have good IDE integration. We have this, which is pretty easy to figure out. And then we have this, which is introspection. We allow you to introspect which targets Meson has built, what files it's going to install, what tests are there, dependencies, everything. And we even have a subcommand to rewrite the build files programmatically. I don't know of any other build system that does this. You only get this sort of thing if you use Visual Studio or something which has its own file format. And we have a lot of IDEs using this stuff. We have GNOME Builder, we have Kdevelop, and we have Eclipse, experimental, and everything that uses CMake can use a CMake wrapper, but it's not, you shouldn't rely on that for production. We also have backend support. If you use Visual Studio or Xcode, you can output the native format for those IDEs, which is really important for people who want to be comfortable in their environment. So in my opinion, Meson is the best general purpose build system that has ever been created. And we're continuously innovating and evolving. And there's a demo which I will explain, which I'll show to explain what I mean. So let's see here if I can get this. Yeah. All right, so we have here GNOME Recipes, which is an app. And let's say somebody wants to build it. So here we go. This is what you do. You run Meson and then a directory, a build dir directory. This will run configure, right? Oh, we're missing a dependency. Oh, and there's other dependencies which we're missing as well. I have to figure out what each of these are from. But what if, instead of having to figure out how to provide these and mapping them to development packages, we could do something really cool. We could have Meson figure that out for us. Okay, it's telling us we can install these optional dependencies. Oh, we can install this. Okay, cool. Yeah, please do that for me. Okay. And it's, what? Oh, we don't have internet here. But if we had internet here, it would install it for us. And then it would work. And you can even change this to install for us. We can just do, we can do warn, and then it will tell us exactly what's missing. It will tell us, for instance, no, not warn, sorry. It's info. So it says, this is not found, but you could provide it by installing this package. This wasn't found, but you can install it by installing this package and this one. One of the major headaches, like For instance, the other day, we were doing a workshop at RustFest on GStreamer and WebRTC, and one of the bigger issues we had was telling everybody what packages need to install to actually run the examples. And this I wrote up yesterday, and it uses PackageKit. So it will work on every distro which supports PackageKit. And it's completely agnostic. It will tell you exactly what you need to build your application. So I think this is something which doesn't exist right now. It's in my personal branch, but I did this in one day. And so it shows you how extensible and flexible Meson is. This kind of integrations are only really possible if you have an upstream that will listen to you, a project that is approachable, and which actually you can talk to, right? But I see you asking, why should you care? Why should app developers care, right? For that, we need to ask ourselves one question. What do app developers want more than anything else? Is it users? Absolutely not. We don't want users. We want more developers. That's what everybody wants. Users just come with complaints. Developers fix things. So how do you get developers, right? Now, for this, there's a simple pipeline, simplified pipeline. So we have, let's say, a user with spare time that finds a small issue. Let's say an incorrect translation, a UI glitch, a bug, whatever else, right? They go to your website, they download the source code, they try to build it, they figure out how to contribute to your project. Then they submit a change upstream, right? They see appreciation for their work. They're like, wow, these people actually like what I did. And then it gets merged, and they're like, wow, I'm hooked. I like this. I want to do this more. And that's how they get hooked. And this is our evil plan as maintainers, to get more contributors. Now, this is a pipeline, right? So let's think of it like a pipeline. You want to maximize the input to this pipeline, more contributors. You want to minimize flow losses. You don't want to turn them away, right? Next step is, and then profit, right? Well, this is FOSS, so no profit. But the pipeline is still there. So now in these steps, notice that the first time that somebody is going to interact with your project is here. The contribution flow is the first obstacle that the user faces. If you turn them away here, they're gone. If they're able to make local changes easily, if they can build your project, then they will submit those upstream. So being able to build your project is really important. In the contribution workflow, your build system must be easier to understand than your code. The first step is the most important one. People can't contribute if they can't build your code, right? And I love what Flatpak and GNOME Builder are doing about this. You can click a button in GNOME Builder and build your project. It's really cool. Unfortunately, they're Linux only. And your apps should be cross-platform. Why is that, you ask? Why should my apps be cross-platform? There are a lot of reasons, and there's a whole talk about this, right? But it all boils down to one thing, in my opinion, and that is mindshare. Mindshare is about, everything is about mindshare these days, right? We want people to know about FOSS. And we want them to see it as better than everything else. That's our goal, right? So we have to be where they are. They won't always be on Linux. We should be everywhere. We should be on Linux, Windows, Mac OS. If it's possible for your application on Android, on iOS, wherever else. Anyway, this is a digression. Let's get back on track. What does the pipeline tell us? The pipeline tells us that more platform support leads to more contributors. The more places you are, the more likely it is somebody will want to hack on your application. And hence, we have to give an excellent experience for contributors everywhere, out of the box. And this is what Meson is for. We did this really well in GStreamer. We have a meta project using Meson sub-projects called GST build. And the current steps for building it on any platform, on Windows, macOS, or Linux, are you install Python, you install Git, you clone the project, and you run Meson build. That's it. And then you run Ninja build, right? That's it. And it works really well. And I think that if every project can do this, they'll make it really easy for people to contribute. And they'll be able to know that your project exists, and they can contribute to your project. And so this is what Meson is about. All platforms, all tool chains, architectures, extensible dependency abstractions which work on all platforms. The thing which I showed you earlier, which works only on Linux right now, it can be extended to use Homebrew on macOS, for instance, or Chocolatey on Windows, or whatever else you want. We have great IDE integration. So, for instance, we have GNOME Builder integration, right? At the same time, you can also have Visual Studio integration in the sense that you can click on a button and download all the dependencies for your project using Chocolatey, right? And we have sub-projects. If you don't want to use an IDE and you want to have work from the command line, that works pretty well too. So yes, Meson is the thing for you to use, and we should all be excited, and we should all move to it from everything else. That's it from me. Questions? That's our website, run with Hot Talk. Don't be shy. You can heckle me too if you want. Any CMake users here?
I have a question.
Yep.
'Cause I hold the mic. You know, a lot of the new languages have their own build system. How does one incorporate? So every new language is now incorporating that kind of thing. So how does that work in relation to Meson?
So there are levels of integration that you can have in a build system. The first level is, okay, you offload the work to a different tool, which then gives you a binary output, which you can then consume, which is what you can do in Meson, which is what the default integration is in all build systems. If you use AutoTools or CMake, you will call a command, it will give you an output, and then you consume that. Let's say a static library, libfoo.a, right? And that's currently, for instance, for Rust integration, with cargo integration specifically. Rust, you can build Rust file, but if you want to download stuff from crates.io and then build everything, for doing cargo integration, currently there are GNOME apps which are using this sort of minimal integration, which is you call an external tool, which gives you an output, which you can do with Meson as well, custom target, right? But there's a higher level of integration that you want, which is you want to be able to control everything about that compilation, about that build. And for that, it needs a tighter amount of integration with the build system. And for that, in Cargo currently, it's not just us that cares about it, other people also care about it. Everybody has their own build systems, and they want to integrate with each other. So for instance, I think it was Facebook, which added support to Cargo for outputting build plans, which is basically you call Cargo with -z, unstable options, build plan, and then it will output a JSON file, which tells you what the compiler wants, what Cargo wants to run. All the compiler commands, all the linker commands, everything. And then Meson would be able to run that, and then tell Cargo, hey, I did all the compilation for you, now just output, like, do the rest of your work, run the program or the test or whatever else. That kind of integration also requires this kind of work, and that needs people to actually care about this and work on that. So it's definitely doable, but it needs people to care about that, and I think the Rust community is pretty welcoming, and so I think that that can be done. For other tool chains, it would entirely be on a case-to-case basis, but like as I said, the levels of what's it called, integration that you want, and you want higher levels. So that starts from low integration, and then you spend time on that. People care more about it. They want more integration, and that gets fixed. So that's how I would say it would happen. That's it then. Okay. Thank you.